All right, so the recording has started. So let's dive into today's lecture. Okay, what we are going to do today. So, we have discussed on decision tree classifier. We know what is a decision tree classifier, but we have not yet seen how to, you know, um, apply the decision tree classifier on a data set. So we're going to look at it today. Okay. And today we're going to look at a particular data set, and we're going to look at how to pre-process a data set, how to prepare it so that we can apply machine learning on that. Because what different processing techniques we need to do, how to split a data set into train set and test set, right? So we're going to see all these things today, and then also how to apply um, a classifier. So today we will definitely look into hopefully decision tree classifier, how to apply decision tree classifier on a data set. And if time permits us, we will also see how to apply k-nearest neighbor classifier on the same data set, okay? And how to interpret results from there. So these are the things that we're going to do today, okay? So let's get started. So I'm going to open up my Jupyter notebook. So here we are. So I go to the Python code. Yeah, teaching. Under that, we have got decision tree. Okay. Right. So we're going to go through this notebook today. I'll upload the notebook as well. So we started with the notebook last class, but I think let's just start from the beginning. Let's look at from the beginning so we are all on the same page. Okay. So can you all see my screen? Yeah, can you all see my screen properly?
Yes.
Okay. All right, so let's get started. Let's see what is the agenda today. We're going to do a couple of things today. Number one, we're going to look at the when we apply machine learning, we need to go through some phases. So we're going to look at all the phases. Some of the phases you already know, but then again, we'll just go through all these things. So first thing we're going to do is we're going to read a CSV dataset using pandas. So you all know how to read a CSV dataset from pandas, using pandas, but we're going to do that because we will have to, first of all, take the dataset, okay? So we learn about how to read, we are going to read a CSV dataset using the pandas. Then before we apply any machine learning, this is very important. Before you do any kind of machine learning if you apply before you apply your machine learning algorithms on your data set, it's actually a very good idea to have a sense of understanding of the data set that you have. Okay. So what we're going to do next is, after we have read the data, we're going to apply different exploratory data analysis technique, or we call it EDA technique. Now, we do the exploratory data analysis technique. That means we are going to explore our data set. Okay, we're going to actually explore our data set. And as we explore our data set, what does it help us with? We understand the data set that we're dealing with. Okay, it would be very improper if you collected a data set, you applied machine learning algorithms on it, you have good results, but you really don't know what you're dealing with. You need to understand your data set, right, Nakina? Okay, so I think the very first thing, once you've collected the data, it's a good idea that we explore the data set a little bit, we understand what we're dealing with. Okay, right. So that's the second thing that we're gonna do, and we're gonna see some EDA techniques that we can look into. Okay, then we are going to apply different pre-processing technique. Now, once you have collected the raw data set, now you need to pre-process this one so that the data set has been prepared to be applied by the machine learning algorithm, so that you can apply machine learning algorithms on the data set. Sometimes you need to actually prepare the data set. So what preparation do you require? What kind of pre-processing do you require? So we'll talk about those things as well. So we'll take a raw data set, we'll explore the data set, we understand the data set, then we're going to apply pre-processing techniques on the data set. Okay, after applying the pre-processing techniques, now we're going to apply the machine learning algorithm. But before we apply the machine learning, remember what we do is we apply the machine learning algorithm on the train set, right, Nakina? And after we apply the machine learning algorithm on the train set, what it creates is a model, right? Yeah. And then we run the model on the test set data and see how well it does it work, right? That's a technique that we can use. Okay. Yes, are you following me with that, Nakina? Yes.
Yes,
Yes,
sir.
yes,
Yeah.
sir.
তার মানে before you apply the machine learning algorithm, you need to actually, because you have collected the data set, you need to split the data set into train and test set, right? So we're going to show you how do you apply this technique called the holdout validation technique, which is really splitting the data set into two parts, training set and test set. So we'll see how to do that. Okay. After we have split our data set into two parts, a train set and a test set, then we are going to apply or use decision tree classifier here. We're going to apply decision tree classifier here on which set? On the train set to create a model. Okay. So once we have applied the machine learning algorithm on the train set, then we are going to evaluate the performance of the train set, evaluate the performance of the model using the test set data, right? So we're going to see how to do that. How do we apply decision tree classifier on the train set, create a model, and then apply the test set on the model, right? And see how well does it actually, classify, right? We're going to see that. And then we are going to also discuss the issue of model overfitting. So there's a lot of things that we want to discuss. So these are the main agenda. And then if we have a little bit of time, we will also try to apply the same idea with a different classifier like KNN classifier. So I'll just write it down here. So, okay. So after that, if we have, we are happy to cover up to this. Then after that, if we have some time, we're going to apply the same idea with a different classifier. So we are going to apply the same idea with a k-nearest neighbor classifier. Now that is okay if we have time. So if we have time, we'll do that. Okay. So that's basically today's agenda. Are we good, Nakina? Yes? Clear? Are we clear what we're going to do today? Yes?
Yes, sir.
Good. So what's going to happen today is after you're done with today's class, okay, you should be able to create, a model for decision tree like this. So this is how a decision tree looks like, right, Nakina? This is the model that you have. This is how you make a decision. Then, is that right, Nakina? Yes. So if the age is less than equal to something, you go on this side. If it's greater than something, you go on that side. That's the entropy value. Okay. এতগুলা স্যাম্পল ছিল তার মধ্যে এতগুলা class 1 এতগুলা but maybe class 0 or class 2, whatever the other class that you have, I guess that's class 0. Okay. All right. So you see, and then you go on. If it's true, then you go on the left, and then you check again, you go on the left, and then when you come over here, you make a decision that this belongs to class 1. Okay. Or if you come over here, it will make a decision belongs to class 0 here or here. And again, if you come to here, you make a decision that it belongs to class 1. So how do you create this sort of decision tree? We're going to look at it today. Okay. So let's get started. Shuru kori amra naki na? Shall we? Okay. Now, so once we have done these things, the next thing that we're going to do is the very first thing that we're going to do is we are going to load some packages, right? Now, let's load the packages that we actually require. Now, I have loaded a lot more packages than I require, but some of the packages we're going to use are NumPy. We need the NumPy library, Pandas, Matplotlib for plotting, Seaborn for plotting. Okay, this is percentage matplotlib inline. We usually write that when we're writing it in notebooks. Okay, and do not worry. This is some sort of formatters and stuff like that. What should be the figure size? You don't really need that, but I just kept it like this way so that it looks good. Okay, that's all. And we're going to use so here you have got certain libraries, but I don't think you need these libraries at all. Okay, but I'll keep it anyway. Okay, right. And then over here, you'll see some other libraries that we're using. We'll use it quite a lot. There's something called sklearn. There's an sklearn library. Now, what's an sklearn library? Let's take let's understand this sklearn library. So I'll write down sklearn, and so you'll understand what's sklearn. So sklearn stands from scikit-learn. So if you go over here, Now, what is scikit-learn? Scikit-learn is basically a library. Okay, right? So I think I can actually see over here what says scikit-learn. So it's written over here. So scikit-learn is a free software machine learning library for the Python programming language. So if you're programming in Python, now we have many machine learning libraries in Python. So one of the machine learning libraries that we have in Python is called scikit-learn. So we're going to see how to use the scikit-learn to do that. So for example, you're applying decision tree classifier. Now, are you going to create a decision tree again from the scratch, or are you going to use a library to actually invoke the decision tree classifier? I think the best thing is to actually, instead of reinventing the wheel, you know what is decision tree classifier, you know how it works. Instead of building the decision tree classifier from the scratch, I think we're going to just use the library to do that. Okay, that's much more easy for us. There is no point of creating a decision tree from the scratch when it's already available in the library. Is that right, Nakina? Clear? Yes? Are we guys okay so far? Hello?
Yes.
Yeah.
Yes.
So we are going to use a machine learning library. So to use all these sort of, things that we have in machine learning. Okay. So we can use this particular machine learning library to the scikit-learn. Now, we also know that we can actually also do it in Weka. So in your project, if you want to do it in Weka, go ahead. I have no problem. But in this course, I'm going to show you a couple of softwares so that you're very much comfortable with different platforms that you can use. So this week, next week, in these 2 weeks, we're going to actually use this library heavily. This is called scikit-learn. So scikit-learn is basically a machine learning library in Python. And you've got all kinds of classifiers that we will be using. Okay, also regressors, clustering algorithms, all these are implemented in the scikit-learn. So all you need to do is you need to invoke them from the library, and you can just apply them on your data set. Okay, Acha. So for that purpose, what we are going to do is we need certain things from the scikit-learn library to be installed. One of them is called, from sklearn.preprocessing, there is something called min-max scaler. You will see that what is a min-max scaler. We'll discuss about min-max scaler. Okay. Then there is something called sklearn model selection. We are going to import something called train test plate. Then sklearn we are going to import a tree. This is to draw the tree diagram. sklearn.tree we are going to import the decision tree classifier. That's it. We're importing the decision tree classifier. Okay. And don't worry about these things. You'll see that. Also, we can import something called accuracy score, confusion matrix, R2 score, lots of things we can import. Later on, I imported some more packages, but you'll see those things later on. Okay. So are we good so far, Nakina? Is it clear? Yes?
Yes, sir.
Okay. So one thing that I would advise you, if you haven't done this, I would advise you to install Graphviz. Okay, so the way you install a Graphviz, you just say pip install Graphviz. Okay, so you have to use your Anaconda prompt. So you go to Anaconda prompt here and you write pip install Graphviz. So if you have not done so, I would advise you to pip install Graphviz. Okay, in any case, so we have imported the libraries that we require. So after importing the libraries, let me run this. There is no problem. Okay. I'm not going to run the install the Graphviz here. I have Graphviz installed already, I guess. Okay, so I don't need to worry about that. So we'll come later on here. So now, very first thing that we want to do before we apply machine learning, before you actually, jump into machine learning, you need to make sure your methodology is correct. This is so important. Your methodology needs to be correct. আপনি যে কাজ করবেন, আপনি যে একটা রেজাল্ট জেনারেট করবেন পরে, you need to be convinced of the steps that you're going to make. So let's actually see this machine, these steps that we are going to actually make right now. So let's see what steps we're going to make. So this is my idea. This is what we're going to do, right? So first thing first is we must formulate a problem. Formulating a problem means we must actually know what we are doing. What is our target? Because if you do not know what is our target, you don't really know what you need to do. Do you need to apply clustering algorithm? Do you need to apply classification? What are you going to do? What are you trying to predict? So these are the things you need to actually, figure out. Okay, what are we going to predict? Okay, so this is the first thing that you should be very clear in mind, because that's your target. That's what you're going to do in this project, right? Okay. So once you know what you are trying to solve, or you formulated the problem, then you go to the next phase where we gather a raw data. So you collect raw data. So you can collect raw data many ways. So you can collect raw data like the ways you guys are doing right now, through questionnaires and things like that. You can collect data from interviews. You can collect data through web scraping. Tickets, of course, if it's legal, you need to check that out from wherever you are actually scraping it from. Tickets. So you can have different techniques of collecting the data. So you gather the data. This is what we do. In our case, we're going to work on an existing data set. So we're simply going to read the data. Okay. Now, here's the bit important. Once you have collected the data, which you guys are doing right now, then what is the next thing that you need to do? You need to prepare your data. So the data that you have collected, that's what we call the raw data. Okay. It can happen that the raw data has a lot of issues. There can be a lot of issues in the raw data. For example, in the raw data that we have, you may have some missing entries. Can you not have some missing entries? You can have some missing entries. You can have some attributes with really large values, some attributes with really low values. So that is another problem you could have. You could have redundant values. You could have many issues. So what you need to do is, once you have the raw data, you need to clean that raw data up, right? So cleaning is required. So you need to clean your data. Right? Now, I cannot tell you that these are the only things that you should do to clean the data, because so whatever is appropriate for your data, you're going to clean up the data that way. So, but I've over here given you a list of the things that you can do. Some of the things can be applicable to your data set. Some of the things may not be applicable to your data set. Okay. So let's look at what are the different pre-processing things that we can do. So the very first thing that I would suggest you to do is to start with EDA. What is EDA? EDA stands for exploratory data analysis. So you're going to analyze the data. Why we want to analyze the data? Because of two things, actually because of multiple things. Number one, it gives you a sense of what's happening. You have a better understanding of your data set. That's number one. Number two, it also tells about what is the state of the data set, what are the issues that you have in the data set. And if you have some issues, then you can actually, take a necessary step, okay, to clean up that problem that you have, right? So we're going to look at all these sort of things, okay? Now, we have over here a number of recommendations that you can actually look into whenever you're doing an exploratory data analysis. Now, when I say exploratory data analysis, you're going to explore the data. I don't mean to say, don't get deceived by thinking that you're going to do it randomly. No. Okay, there are certain things that you'd like to look at. So what are the things you're going to look at? So we want to look at how many, so for example, how many features you have. That's something you want to look at. Okay. All right. And what are the observations that you have? Protect a feature value quite unique values key values. We can see that tells you something about the data set. How many elements are there in each feature? প্রতিটা ফিচারে কতগুলো এলিমেন্টস আছে, so unique elements, unique values, we'll see that. Is there any null values মানে কি মিসিং এন্ট্রিজ, কোন একটা পার্টিকুলার এন্ট্রি মিসড আউট হয়ে গেছে, ঠিক আছে? হতেই পারে না তুমি যখন কোয়েশ্চেনার ইউজ করছো, there could be a question যে somebody did not answer, so you have a missing entry there. So if you have a missing entry there, what are you gonna do? So if you have null values, missing data, what are you gonna do? Also, if you have redundant data, ঠিক আছে? Okay, redundant data মানে হচ্ছে duplicate আসছে, what are you gonna do? How can you actually tackle that? So all these sort of things you need to look at. So you're gonna investigate the different distribution you have. Distribution of what? Distribution of the different features you have. Okay, and relationship. So that gives you a better understanding of the data set itself. So আজকে আমরা we're going to look into some EDS. We're going to see some of these things that we're going to do. Okay, you'll see that. And now once you have a good understanding of the data set, the different issues that you have in your data, now you can start your data cleaning, procedure. So you're going to start doing your data cleansing or data cleaning procedure. You may need to aggregate data, but many a times you may not need to aggregate data. Bring all data sets together. এটা হতে পারে data set অনেক জায়গা থেকে নিয়েছো. You need to actually join them and things like that. ঠিক আছে? But in our case, we will not be doing that. So, but হতেই পারে, তাই না? নাকি না? Yeah. You may need to normalize and scale your data. Okay? হতে পারে যে একটা ফিচারে ভ্যালুস গুলো অনেক বড় বড় আসে, আরেকটা ফিচারের ভ্যালু গুলো ছোট ছোট আসে। সো বেশি বড় যেটা সেটা আর ছোট যেটা প্রবলেম হচ্ছে কে নিয়ারেস্ট নেইবার। খেয়াল আছে আমরা যে ইয়ে করেছিলাম, কি বলে, স্কেলিং করেছিলাম। ডু ইউ রিমেম্বার দ্যাট নাকি না? নরমালাইজ করতে হচ্ছে ডেটাগুলো, মনে আছে নাকি না? ইয়েস, you guys remember that? Hello, are you there? Can you hear me? Okay.
Yes,
anyway, we'll talk about scaling. Okay? So how do you do scaling? If you have categorical features, well, machine learning algorithms are not good at tackling categorical features. Like some classifiers can be okay with tackling the categorical features. There are many machine learning algorithms that are not good at tackling categorical features. So you need to convert the categorical features into some numeric representations, okay? And we'll talk about how to do that as well. So these are all the cleaning process that we do, okay? Then there's something called feature importance, feature selection, okay? All right, we'll talk about feature importance today, but feature selection is something probably we'll not be able to talk about it today, but we'll see what we can do in the next step. And there's also something called feature engineering. We're not going to look into feature engineering today, okay? So, but we're going to do quite a bit of things in the data process. Machine learning is যতগুলো step আছে, this is the most time-consuming step because you got to do quite a lot of things carefully. So data pre-processing is quite a time-consuming step, okay? After we have done the data pre-processing, what's the next thing that we're going to do? So we do the data pre-processing in order to convert the raw data, okay, or in order to make the raw data suitable in a suitable format, in order to convert the raw data in a suitable format for machine learning algorithms to work on it, right? So after you're done with the data pre-processing step, it just means it is now in a good state for your machine learning algorithms to actually be applied on it, okay? So in order to apply your machine learning algorithms on it, what I'm going to do first is I'm going to split the raw data that we have. Although I'm saying it's the raw data, but it's not really the raw data. We're splitting the pre-processed data. We took the raw data, pre-processed that, and then we're splitting the pre-processed data. Am I clear, Nakina? Yes? Are we good? Okay. So when I split the pre-processed data, we split it into two parts, training part and test part. But there are other people who do training, testing, and evaluating data set. But আমি এখানে দুটো পার্টে ডিভাইড করব, একটা হচ্ছে training set, একটা হচ্ছে test set. So once we actually have done training and test set, what we are going to do is we are going to take the train set and we're going to apply the machine learning algorithms on the train set. So once we have applied the machine learning algorithms on the train set, we're going to evaluate how well our algorithm is working using the test set data. Am I clear, Nakina? Yes? Chikacha? Yes?
Yes, sir.
Okay. In many cases, what they do is when we apply the machine learning algorithm on the test set, they get some accuracy and they actually tune the parameters and run it again so that accuracy can be enhanced, okay? But today we're not going to talk about how to tune the parameters. So we're going to just split the raw data into two parts, train set and test set, apply the machine learning algorithms on the train set to create the models, and then we are going to then evaluate how well the model is actually predicting by using the test set, by applying the test set on that model. And once we have applied the test set on the model, that's the prediction that we are actually generating. So that's basically what we're going to do. So hopefully by the end of today's class, you're going to see all these steps today on a particular data set that we have. So let's begin. So did you understand the methodology that we are embracing here? Yes or no?
Yes, sir.
Okay, so once we understand the methodology is very, very important. Okay, so once we have understood the methodology, I'll go ahead and we will start discussing what we're doing. So first is problem formulation. We need to know what we are exactly doing. What are we trying to solve? Now, we are going to discuss a data set, okay? And the data set is about customers that the company has, okay? So it has a lot of things about the customer, and the customer may either churn or may not churn. Churning means what? What does it mean when I say customer is churning? What does a churning customer mean? Churning customer means that this customer is no longer doing the business with that organization. It's leaving the organization. And not churning means this customer is staying with the organization. Okay. And that's a very, very important thing for any organization. So you will basically see, if you do a little bit of a Google search, you'll see that there's a lot of papers on, whether a customer is going to churn from an organization. Can you guys mute yourself? Yeah, mute yourself, please. Okay. So if you do a little bit of Google search, I don't want to do it right now because it's going to take some time out. But if you do a little bit of Google search, you'll see that there's a lot of research that goes on in this area, whether a customer is going to, churn out of an organization, or is he going to stay with the organization, things like that. And this is extremely useful for any organizations. They want to know whether they're losing any customer or not. So we just want to see whether we want to predict if a customer is going to churn or not. And that's basically our problem that we are trying to solve. This is our problem formulation. So we would like to, create a target. What we are trying to do. What are we trying to solve? We are trying to predict if we have any customer, if we have a customer that is going to churn or not churn. Okay. Is it clear, Nakina? So are we clear what we are going to do? Yes?
Yes.
Okay. So once we are clear with that, so the next step that we're going to do is we are going to, read the raw data. So we have the raw data. So let's say the organization has collected some data, okay? And the data is available in a CSV file, okay? So I think I have already uploaded that CSV file, so you can have that. So in any case, so we'll read the data, read the raw data, okay, using pandas. So how do you read the raw data using pandas? We say pd.read_csv. These are the things we have done before, and that we give the name of the file that we're reading. The name of the file is churnrawdata.csv, and what it does is whenever you do pd.read_csv, it returns a data frame. So you're storing that data in a data frame called raw data. So raw data is over here. What raw data is? The pandas data frame. So you have stored the data in this data frame called raw data. So because it's data set is now stored in the data frame called raw data, let's look at some of the things that we have in this data set. So for example, let's print the shape. So if you want to print the shape, you just write print raw_data, that's the data frame dot shape, okay? And if you want to see the first 5 instances so that you have a better understanding of how the data looks like, let's just do data frame, which is raw data dot head. That's going to run the first 5 rows. So if you run this one, we'll see here. First, it printed out 10,000, 14. What does that mean? It printed the shape of this raw data, which is 10,000, 14. One good idea is always, whenever you're doing this, you're reading these things, you record the important points in a data set. So for example, we have just found that there are 10,000 rows and 14 columns in the raw data, right? So you can actually create a notebook, or you can actually create a cell in the Python, and you can write down, you can list down all these important things that you are actually finding during your investigation. Why are you writing these things? Number one, you are not doing this one just because you need to do that. You're doing this one so that you have a better sense of it. So keeping a record of it, okay, will help you to, once you're finished doing that, go back and see, okay, what were the things I observed, right? So it helps you to see that. Secondly, another thing that it helps you in, so right, note all your observations someplace. Okay, I haven't done here, but you should do that. Okay, because it actually helps you to understand the data and keep a record of that, so that after you're done with the observation, you can go back and review what you have observed so far. So once you have seen that, it may occur to you, okay, what about this, what about that, so you can do further investigations, right? Yeah. So that's one advantage of that. And the second advantage that you have is when you're going to write a paper, okay, all your observations would be very, very useful information to write in the paper as well. Right, Nakina? So that also helps you a little bit. Is it clear, Nakina? Are we getting this? Yes, sir? Everyone good? Okay. Right. So I now from here see, when I do the shape, it gives me the shape. So I know there are 10,000 rows. That means there are 10,000 data, okay, instances, and there are 14 columns. So these are the things that we know. Now, when we ran the head, this gives me the first 5 rows. So these are the first 5 rows that we have. Okay, let's look at what are the things that we have. We have something called a row number. Well, do you think a row number is a useful feature? No. Then a row number is not a very useful feature. Now, understand that. Do not say a unuseful feature gulo keno rakhche karon je tomar question e banaয় she je machine learning er lok ta kintu na, he doesn't have the same target as you have. ঠিক আছে? Clear? So there could be certain things that might not be very much important for us from the machine learning perspective, but that's okay, we'll figure out. ঠিক আছে? So he had a row number. Okay, customer ID. So customer ID is a typical ID of a particular customer. That's also not very useful for us. Customer ID just specifies a particular customer. So that's also not extremely useful. Okay, then we have got the surnames of different people that we have. This customer ID was the surname. That's also not very useful for us. Okay. Then there's something called credit score. Maybe a credit score is a value. It's a useful value that tells us how much interaction that person had with that particular organization. Someone with a credit score of 619 is more valuable than someone who had a credit score of 502, maybe. So it could be a very important attribute. So it's a good idea whenever you're going to apply machine learning, okay, you should know what each of these things mean. Okay. All right. So whenever you are applying data science, machine learning, you need to yourself understand the data. As well. Okay. What do they mean? Okay. Next one is geography. Geography basically tells you your customers. Where does your customer reside? So like the first customer that I see over here is from France. The second customer here is from Spain, and so on. So I don't know France and Spain and stuff like that. Okay. So it tells you where these customers are from. Gender just tells you the gender of the customer. Is it a male or a female? That could be a very useful information for us as well. Okay, right? Because maybe the way the male makes a decision is very different from the way the female makes a decision. So that could be also something very, very useful for us. Age tells you about the age of a person, maybe very useful information. Tenure, there's something called tenure, how many years that particular person had been doing business with this organization. For example, the first person over here had been doing 2 years of business with the organization. The third person here had been doing 8 years of business with the organization. This tells you about the balance that person has. Okay, number of products, I don't know what it means, but maybe number of products he bought or whatever. Does he have a credit card? 1 means he has a credit card, 0 means he doesn't have a credit card, right? Nakina. Okay, it's a she actually. In fact, she has a credit card, she doesn't have a credit card. This customer has a credit card, and so on. Active member, is the person an active member? Some of them are very active, some of them have been there with the organization but have been inactive. May not been active for a long time. So whether they were active or inactive, that's also there. And we also know information about their salary. So we may not know the exact salary that they get, but maybe maybe this organization has actually done some analysis to estimate the salary they could have. ठीक है? And finally, they actually have or also have information about the customer, whether this customer has actually churned out of this organization or not. For example, the first customer over here, I can see that she has exited this particular organization, so she has churned out. Okay, the second customer here did not churn out from this organization, so she's staying with the organization. So that's a useful information for us to actually find out that who is going to churn and who is not going to churn. That's the model we would like to create. Are we okay? Did you understand the data set? Yeah. Do we have a better understanding of what the data set we're dealing with? Yeah. So whenever you do something, it's a good idea to go through these things carefully, and understand yourself. And whenever you have an observation, keep a small note of that, okay? Because that's always very, very useful. Okay. So I think we got more or less like what this data set is telling me. And if you count the number of columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and last of the exited or not, that's a 14. So we have 14 columns, and this, you can see we have 14 columns altogether. Okay, so we just read the raw data into our Python. So we are done with this step. If you see, we have gathered the data. Okay, well, maybe the organization has gathered the data through some means. Okay, and now you have read the data. Now we are going to go to the next step, which is a very important step called the data pre-processing step. So we're going to pre-process the data. Okay, so that why do we pre-process the data? We pre-process the data because the raw data that you have may not be in a format, may not be in a format for machine learning algorithms to work on it. So we need to actually pre-process that. So we'll do some exploratory data analysis now. We'll see that. And we'd like to understand the data a little bit better. So I've done a bit of data pre-processing, a bit of EDA. So we'll see this EDA stuff. Okay. All right. Let's get started. So let's start with the data pre-processing. The first thing that we're going to do, we are going to investigate all the elements within the features. Okay. Remember, one of the things that we want to see over here, we said when we start with EDA, one of the things we do is we're going to see the number of features we have. We already know we have altogether 14 columns. That means 13 features, and one of them is the target. With 13 features and more feature that's not very useful for us. Like for example, row number, customer ID, customer surname, egola may not be very useful for us, so we will get rid of them as well. That's what's happening in the pre-processing. So we're going to look at what are the features you have, and we want to see the elements in the feature, number of elements in each feature. How many elements does it have, or how many unique elements does it have in each feature? So we're going to investigate that. So investigate all the elements within each feature. So I wrote a very small code over here, small function over here, and I would like to explain you what this function is telling me. Okay, so what's the name of the data frame here? এখানে data frame যে data read করলাম, read করে একটা data frame রাখছি. What's the name of the data frame here?
Raw data.
Raw underscore data. That's the name of the data frame. So I'm going to now investigate the data frame. A data frame প্রত্যেকটা ফিচারে unique কয়টা values আছে, I want to figure this out. So we wrote a function. I want you to see the function here. So we ran a loop for column in raw data. For column in raw data means what? A raw data te যতগুলা columns আছে. So we're going to look at all the columns in the raw data. ঠিক আছে? Okay? Right? Yes or no? Okay, for columns in raw data, first of all, raw data প্রথম কলামের জন্য আমি যদি এটা লিখি raw data column dot unique, raw data column dot unique বলতে কি বোঝায়? আচ্ছা, raw data column মানে কি? Can anyone tell me what this raw data column means?
All the features.
Okay, column in the raw data. Column is the first column. So যখন লুপটা স্টার্ট হচ্ছে, first column First column টা কি আমার এখানে? What is the first column over here? Row number, right? So it's going to apply on the row number. তারপর loop করছি যেহেতু, তারপর it goes to the second column. তারপর it looks at the third column. So it looks at column by column, right? নাকি না? Yes? So for each column, what it's going to do? First, raw data column dot unique. Raw data column means we just take that entire column. So let's say for the first time when we go inside this loop, it's going to look at this entire column. And dot unique বললে কি হবে? ওই কলামে যতগুলো ভ্যালুস আছে, কলামে কতগুলো unique values আছে. Okay? Maybe if you see over here, geography, for example, that's France. This is France is a unique value. Spain is a unique value. Again, we have the same France. So we want to see how many different unique values do we have. So for each column, we want to find out how many unique values do we have. And we're going to store all these unique values in a list called unique values. So unique values here is a list containing the unique values for each column. So first time loop যখন করছি, so first column এ unique values কটা আছে সেগুলো আমি unique values এ রাখছি. Second time যখন loop করছি, second column এ unique values কতগুলো আছে সেগুলো আমি unique values এ রাখছি, right? নাকি না? Yes. So we're keeping how many unique values that we have in one column. So once we have kept all these unique values, so dot unique will give you the unique values. Is it clear নাকি না? Did you understand this নাকি না? আমার কথা বোঝা গেছে নাকি না? না বুঝে গেলে বলেন, I'll help you out. Okay, let me show you this one. Let's create a cell. Now, if I say, look at this one carefully. Raw data is the data frame, right? Yes. এবং আচ্ছা আমার কলাম কাটা আছে, বলেন তো কলাম কাটা আছে. Let's see. Raw data dot columns যদি বলি, so how many columns do we have?
14.
I'm sorry. Now, what are the columns that we have? Okay, these are the columns that we have, right? Nakina, these are the columns, right? Is it clear, Nakina? Can you see that? These are the columns?
Yes, sir.
Okay. Now, if I now say that can check on that column name, raw data is the data frame. Then I'm going to take this column called geography. Okay. I take this column called geography. So I'll just copy the geography. I'm being lazy a bit. Paste. And I now paste it, paste. Okay. So if I do raw data geography, what will it do? Anyone? কি করবেন? তার মানে raw data তো হচ্ছে data frame টা and then column name তো বলছি geography. So it will go to that particular column called geography. Geography তে যত ভ্যালু আছে সবকটা ভ্যালু এখানে স্টোর করছে. Am I clear নাকি না? Yes. So if I just raw data geography, that's huge. 10,000 values থাকবে, ঠিক আছে? এবং প্রথম জন ফ্রান্সে, সেকেন্ড জন স্পেনে, থার্ড জন ফ্রান্সে, all these things are written, ঠিক আছে? So you see it says dot 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 because it's just too big. It has understood here is too big. Clear নাকি না? But আমি geography dot unique যদি লিখি, let's look at this one. If I write dot unique, it tells me a geography column এ কতগুলো unique values আছে. The unique values that we have are France, Spain and Germany. Am I clear নাকি না? Is that okay? Understandable?
Yes, sir.
Yes. So that we understand this, okay? Now we're going to come over here. What we're going to do is for each of the features, we want to see how many unique values we have. So for each column, so let's look at, let's say when we look the first time, so we have the first column in the raw data column dot unique will tell me how many unique values do we have for that column. So we store it here. And here, when I say length of unique values, the kotogula unique values, length is this one, nr dot values, number of unique values, okay, is the length of the unique values. How many values do we have? Now we make a small rule. If the number of unique values is smaller than 12, number of unique values is large, like for example, row number 10,000 instances, 10,000 different row numbers. Yeah. You don't want to print out all 10,000 row numbers. So it's just going to be too clumsy. So that's why we are making a small rule here. If the number of unique values is smaller than 12, we say 12, you can change with that. Then I'm going to print out the number of values for the features are, first feature that we're printing is dot format column. So column namta ki, column namta, tapor I'm going to print out here the number of unique values, কতগুলো unique values আছে, এরপর তারপর আমি কি প্রিন্ট আউট করছি, the unique values. Unique values কি কি আছে সেগুলো print out করছি. I'm printing out the unique values as long as the number of unique values is smaller than 12. But if the number of unique values is large, let's say it's greater than or equal to 12, then I'm printing out the number of values for the features. I'm printing out the column name, and I'm printing out how many unique values does it have, but I am not printing out what are the unique values that you have because the unique value is quite large, right? Is it clear? So that's a small function we have written. So if we evaluate the function, so let me run this function. So you now see over here, so for each features it's going to do. So there are 14 features. So you'll have 14 lines of prints. Yes? Okay. So first feature was row number, and there were altogether 10,000 row number. 10,000 rows, so 10,000 unique values of rows. All right. Customer ID, there are 10,000 unique values. So that means each customer has a unique ID. So there were 10,000 rows. So that's why you had a 10,000 unique customer ID. If we look at surname, I can see there are 2,932 surnames. Okay. All right. Doesn't tell me a lot of information, but we're just going to go ahead and see whether we get some useful information out of these things or not. Credit score. So we see that we have 460 different credit score values. Geography. There are only three different geographies where the customers come from. That's a useful information. And it also prints out all those places where the customers come from. So the customers for these organizations are typically from France, Spain, and Germany. Am I clear, Nakina? Is that okay? So we now have found a very interesting information about this data set, is that all these customers that we're looking at, they really come from these three European countries, the France, Spain, and Germany. Is it clear, Nakina? Are we getting this? Yes. Also see, for this particular feature, not only it printed out the feature name, which is geography, and how many unique values is 3, it also printed out what are these unique values. It's because this is less than 12. 3 is smaller than 12. So I'm also printing out how many unique values do we have. Clear, Nakina? Yes? Do you get it? Are you getting this, Nakina? Are you all right? Hello?
Yes, sir.
Yeah. Next one. What about gender? There are 2 different genders, female and male. 70 different age values. So 70 is larger than 12. We don't print them out. 11 different tenure values. Well, these are not sorted. Sorted bhabe nai. But 0, 1, 2, 3, 4, 6, 5, 6, 7, 8, 9, and 10, I guess. So there are some people who were there for less than 1 year with this organization. There are some people over here who've been with this organization for 10 years. 10 years, 8 years, and so on. Okay, 11 different years that we see. Number of unique values for balance is 6,382. Doesn't tell a lot of things. Number of products, unique number of products that so these 10,000 customers bought would be 1, 3, 2, 4. So that's an interesting thing. We can see that the maximum number of products they bought it was 4. The minimum number of products they bought is 1. So there's one interesting thing that I can see, that I don't have anyone over here with 0 products bought from the organization. Clear, Nakana? I can see that. Okay. So has credit card. There are 2 values for that, 1 and 0. Of course, I understand. 1 means he has a credit card. 0 means they don't have a credit card. Is active members 2. 1 means he's an active member. 0 means he's not an active member. Estimated salary. There are 9,999. Unique estimated salary for these 10,000, customers, right? And exited. Well, did he churn or not? 1 means he has churned or exited from the organization. 0 means he did not churn out from this organization. So these are some of the information that we have. So you see, we are doing EDA or exploratory data analysis. It's giving me certain information about the data. So right now, we now know that, the customers we have mainly come from 3 countries, France, Spain, and Germany. We also know that these customers usually stayed with the organization from 0 to 10 years. Okay, right? Okay, and we also know that they bought 1 to 4 products. There is no customer who did not buy any product, is not there. So we get some ideas about this data set. Is that okay, Nakina? Clear with this? ঠিক আছে?
Yes, sir.
Okay, the next thing that we do over here is, let's go over here. I'm going to write a small code here. Raw data, that's the data frame, dot is null. Does it have any null value? Null value means what? Missing entries. কোনো একটা value নাই. Dot sum college will aggregate for each of the features. So if I run this one, it's going to aggregate for each feature. Okay, row number এই কলামটা যেটা ছিল, এই কলামে কোনো ইয়ে আছে নাকি, কোনো মিসিং এন্ট্রি আছে নাকি, কাস্টমার আইডিতে কোনো মিসিং নাম্বার আছে কিনা. So we are aggregating all these things over here and just tells me row number, there's no missing entries here, customer ID, no missing entries here. So none of the features have any missing entries. So because they don't have missing entries, we don't have to deal with this issue. But আপনারা যখন করবেন তখন it could happen that there are some missing entries, right নাকি না? Missing entries থাকলে মানে you need to tackle the missing entries, ঠিক আছে? So what kind of things I can do, we'll talk about these things, ঠিক আছে? But right now for this particular data set, we see that for each of these columns that we have, they don't have any missing entries. Is that okay নাকি না? Clear? Are we good? Yes. Okay, so then raw data.columns, I just did that because I just wanted to copy things. So we are printing out all the columns. So now we are going to do some interesting pre-processing. Okay, so we have explored the data set a little bit. We have more exploration left. Okay, but right now let's do some pre-processing. Acha, এই যে আমাকে বলেন, দেখে বলেন এখান থেকে, এই যে আমার data set আছে, এই যে, let's look at the first 5 rows here. Okay, which columns do you think are unimportant for machine learning purpose? Which columns do you think are unimportant for machine learning purpose?
Row number, customer ID, surname.
Yeah, basically row number tells you the row number. Customer ID is a unique value to identify a customer. A surname is just the surname of the person. Maybe these 3 features are not so important. Okay, so what I have done right now is, if you go over here, let's see, right over here. So I'm just raw data.columns because I was just lazy. So I printed out all the column names, and now I know these are the columns I do not need. I do not need the row number, customer ID, and surname. So 18 bad de baki go credit score, geography, gender, age. I just copied them in the list. Can you see that, Nakina? Yeah. So তার মানে এই লিস্টে আমি কতগুলা কলামকে বাদ দিলাম বলেন তো আমাকে? How many columns did I leave? The 3 columns that I do not need. That's the row number, customer ID, and surname. Clear nakina? Is that okay? Yes. Hello.
Yes.
Yeah, baki sub columns ke rakhlam. So I create a list of columns. So this is how I write a list. Okay, this third bracket open, third bracket close. We write a list and we wrote all these column names that we want. Okay. So I'm listing out the important columns. The less important columns are something that I did not include. Now let's create a new data frame. How do you create a new data frame? So let's call the new data frame as raw data 2. Okay. So what it's going to do, I'm going to take the old data frame that we have, which is raw underscore data, and raw underscore data মধ্যে আমি just লিস্টটা দিয়ে দিলাম my list. My list-এ এই 3টে কলাম নাই. So 18টা কলাম ছাড়া বাকি যতগুলো আছে সবকটার ভ্যালুস গুলো আসলো, and this is stored in a new data frame called raw data 2. Clear nakina? So now in this raw data 2 data frame, what I have really done is I have actually taken only those data that is important for me, and those things that are not important for me, like row number, customer ID, and surname, I just ignored them. I did not take them. So now if I do raw data.2.head, okay, so if I do that, actually let me write another thing. Let me write print raw underscore data 2 dot shape. Let's look at the shape as well. Okay, so if I print this off, okay, let's see what we get. So when I do that, I see over here raw data 2 dot shape যেটা সেটা print করলে কত আসে 10,000,11. So I have all the 10,000 rows, but how many columns do I have? 11 columns. Raw data তে কতগুলো columns ছিল মনে আছে?
14.
14. Now we have 11 columns. that is just telling you এই যে তিনটা কলাম যেগুলো বলেছি, these are not important for my machine learning, I got rid of them. And in fact, when I did a head over here, you can see the first 5 instances of these raw data 2. Okay, and you see that this row number, customer ID, and surname are absent over here because we got rid of them. Is it clear, Nakina? Yes. So that's the first pre-processing we have done. What is the pre-processing we have done? The features that are not important for us, we just got rid of them. Is it clear, Nakina? Yes. Okay. ঠিক আছে আমরা নাকি না?
Yes, sir.
Okay, one of the things I always advise is you could say that আমার এত কষ্ট করা কেন দরকার, আমার কেন প্রোগ্রামিং করা দরকার, I could have just opened up my CSV file, ওখান থেকে ওই কলামগুলোকে ডিলিট করে দিলেই তো হয়ে গেল. I could do that, but I do not want to mess with my raw data. Raw data তে আমি কিন্তু চেঞ্জ করছি না. I kept it as it is. ঠিক আছে? Okay? And then I'm just programming them because so that it's much easier. Okay? All right. So I do not want to lose my original data. So that's why I do not change in the original data. Okay. So that's there. So we have now found a new data frame with the unimportant features dropped from the original data frame we have, right? Nakina, is it clear? Yes. ঠিক আছে নাকি ঠিক নাই?
Yes, sir.
ঠিক আছে. Okay. Now let's visualize the data set a little bit. Now there is something called SNS Seaborn, there is something called pair plot, but I want you to be very, very cautious. If you have a lot of data, this is going to take quite a time. So you need to make sure that if you have a lot of data, lot of features, let's say extra feature, I would advise you not to run this SNS pair plot. SNS pair plot টা কি করে সেটা হচ্ছে প্রত্যেকটা নিউমেরিক্যাল ফিচার এগেইনস্ট প্রত্যেকটা নিউমেরিক্যাল ফিচারস এগেইনস্ট প্লট করে, ঠিক আছে? So I'm going to write SNS, that's the Seaborn library, dot pair plot function দিয়ে use করছি. I'm telling you where do I get the raw data from? I'm taking the raw data from raw data 2 data frame, and I kept hue as exited. If is someone exiting or not? So this is something we would like to visualize. So I kept it as hue. Remember, আমরা যখন Seaborn করেছি, we discussed about this hue, right, Nakina? Yeah, and hue is used for categorical values. Now, although they are 1 and 0s, but they're really 1 means he has exited, 0 means he has not exited, right, Nakina? Yeah, so that's fine. When we hue that, and you see that it's going to take a little bit of time. So I'm going to run it in any case, and we'll see what happens. And you see it's actually still running. It's going to take quite a lot of time because because you're running everything against everything. You're plotting a graph for everything against everything. Okay, let's just wait for a little bit and let's see what happens. So if you have too many features, like 100 features, 50 features, I actually advise you not to write the SNS pair plot. Okay, so here's a little bit of caution that I've given you. It takes a lot of data, so we need to limit the data. So we need to make sure that we actually do a pair plot for what we are interested in. Okay, so you see we have got a graph. Okay, everything against everything. For example, here credit score against credit score, I guess. নিচে হচ্ছে credit score plot করে এটা আসবে, ঠিক আছে? Anyway, আমরা যদি credit score against age plot করি, so this is what we get, ঠিক আছে? Okay, so there's a lot of things we get, and some of these definitely blue colored, some of these are in orange color. Why is that? Because blue means is 0, that means the person did not exit. 1 means orange, the person has churned or exited this particular organization. Okay? So you can see a lot of interesting things. So here is, I think this is for the number of products. There are 4 products, 1, 2, 3, 4. Okay, if I see that, a column number of products. So there are 4 products, 1, 2, 3, and 4. And you can see if you have large product number, okay, like 4A, সবাই কিন্তু চার্ন করে যাচ্ছে। 3তেও কিন্তু মোটামুটি সবাই চার্ন করে গেছে except a few here. I can see 1, 2, and 3. এই তিনজন বাদ দিয়ে বাকি সব কিন্তু চার্ন করে। তার মানে এখান থেকে আমি একটা খুব ইন্টারেস্টিং অবজারভেশন করতে পারছি না? Those who have more than 3 products, that means 3 and 4 products, they mostly have churned out. Clear na kina? Yes or no? Right? Correct? Can you see that? Hello?
Yes, sir.
Yes.
Yeah. So this actually helps you to see and visualize your data set. It helps you to see a lot of things about what has happened. And then once you've seen that, now also age ticker, I'm sure I can see some interesting things about age. Like look at this age. If you see this age, I can see something. Now this there is an age range over here. এই যে আমার mouse যেখানে hover করছে orange ইয়াতে, these are the age, this is the age range where people mostly churns out. তার মানে less than 40 years old but above I guess 70 years old they don't churn, but মাঝখানে কিন্তু অনেক churning হচ্ছে, ঠিক আছে? So it also tells me that age is an important factor that tells you যে what kind of people are churning and what kind of people are not churning. Correct, Nakina? Clear? So you can do lots of different kinds of analysis. Now, after you've done this sort of analysis, if you want to see some more detailed analysis, let's say, for example, age I want to see, I can draw a plot like SNS or count plot. Count plot usually draws histograms, okay? It counts, but let's say x-axis age plot করেছি, আর data frame হচ্ছে raw data 2, আর hue হচ্ছে exited. Now, when I run this one, so we just see over here, okay, it takes a little bit of time, okay. Age, so hue can be exited, okay. So you see the orange one or the brown one rather, okay, are exited people. So exited people there গ্রাফটা হচ্ছে এইভাবে ড্র করা আছে, আর যারা এক্সিট করে নাই তাদের গ্রাফটা অনেকটা এরকম প্লট করা আছে। ক্লিয়ার না কেনা? ইজ দ্যাট ওকে? সো আই থিঙ্ক আই ক্যান সি ওয়ান থিং হিয়ার, দোজ হু হ্যাভ এক্সিটেড they mostly have normal distribution, এটা মোটামুটি একটা নর্মাল ডিস্ট্রিবিউশন, আর এটা হচ্ছে একটু রাইট স্কিউড ডিস্ট্রিবিউশন দেখা যাচ্ছে, ওকে। সো মানে these are things that you can observe about a data set. So if you want to observe further, you can do further plots like number of products against মনে হয়েছিল, so we plotted a graph here, number of products on the x-axis, ঠিক আছে, okay. So actually let's do this one. We don't plot anything on the y-axis. Let's say we don't plot anything on the y-axis, so I'll get rid of that. Okay, I just plotted the number of products on the x-axis. Okay, raw data 2 Tikanichi data frame comes from raw data 2 and hue is exited. Let's plot that and see what happens. Okay. Oh, we don't get in. Why is that so? Number of products. Okay, so for some reason we do not actually get a very interesting graph for this one. Okay, but if I plot y axis যদি কিছু একটা দেই, what we can give, credit score was one of them. How do you give the credit score? So credit score is this one, right? So y-axis is usually a credit score thing. Let's put something on the credit score here. Oh, Ashbena, because I'm doing a scatter plot, right? That's why. Okay, sorry. It's a scatter plot. Scatter plot means x-axis y-axis y-axis is thing. If I change that to count plot, let's do count plot. Now it should be fine. So yeah. So we get a histogram, right? Count. So we can see over here, when we have for customers with one product or two products, yes, the brown ones is like the churning ones. So one product churning, two products churning. 3 and 4. 4 এ দেখো churn করছে কম, that's true, but not churning একজনও নাই। তার মানে 3 or 4 এ mostly they're churning out, ঠিক আছে। one product অনেক churning হচ্ছে, okay. এটা might be a better idea than number না করে percentage হিসেবে plot করলে maybe we'll get a better idea, right নাকি না? Yeah, did you get the point নাকি না? Is it clear? Hello?
Yes, sir.
So you get some information, so if you are, once you have visualized using the pair plot, now if you want to visualize further, you can draw the respective graphs and understand what this tells you about the data set. Anyway, so that's what we would like to stop here, okay? Because we can do more visualization, but we wanted to stop because we want to see some more things, okay? Now I want you to see this one carefully, okay? We want to, okay, let's do one more visualization. We want to investigate the categorical plots. What is categorical plot means? So there are some, attributes we have which have numerical values. So these are numerical variables. Some of them has categorical values, and therefore there are categorical variables. So let's see which are the categorical variables. So if I do raw data 2.head, so if I look at the first 5 instances, just to get a feeling of this. So credit score, is it numerical attribute or is it a categorical attribute? What do you think? Credit score, is it a numerical attribute or a categorical attribute? Numerical attribute means it has numeric value, numbers. A categorical means what? Labels, really, okay? So credit score, is it a numerical attribute or a categorical attribute? Quickly. Numeric. So we want to now investigate only the categorical attribute. So let's see the next one. Geography. Is it a numerical attribute or a categorical attribute?
Sure. Categorical.
Categorical. They come from either France, Germany, or Spain, right? Categorical. Gender, what do you think?
Categorical.
Categorical. Age?
Numeric.
Numerical. Tenure?
Numeric.
Well, it is numeric, but I can also say it can be categorical because we have just only 11 different values or 10 different values, I guess, right? 10 different values, I believe, right? So I can also take it as categorical as well. Balance is definitely numeric, right? Number of products, the number of products are 1, 2, 3, and 4. Remember that? Or the unique values, number of products, yes?
Yes.
So I can say that's categorical of those who bought one product, those who bought two products are in one category, those who bought 3 products are in one category, and those who bought 4 products are in one category. So although the values are numerical, but I can still classify them as categorical. Yeah. So let's say we can then classify this as a categorical attribute. So we can classify it as a numerical attribute as well. We can also think of it as a categorical variable as well. Has credit card?
Categorical.
It's definitely categorical. The 1 and 0, you can say it's number, but really, what does it mean? 1 means he has credit card, 0 means he has no credit card, right? So basically, we're categorizing them as whether they have a credit card or do not have a credit card. So it's a categorical value. Is active member, whether he's an active member or not an active member, it's definitely categorical attribute. Estimated salary, well, that's a numeric attribute. Exited is my this is something we want to predict, so we do not want to worry about this one right now. Okay? So let me therefore make a list of categorical features. So I wrote here CAT features, categorical features, and the categorical features that we have listed are geography, gender, tenure, number of products, has credit card or not, or is an active member or not, right? Yes, these are our categorical features, right? Clear? Hello?
Yes.
Yeah. Now we are doing something interesting here. For f is a variable in cat features. So প্রথমে f এর value is geography, তারপর f এর value হবে gender, and then f এর value হবে tenure, then number of products, then has credit cards, then is active member, because it's a loop. So for f in categorical features, we're going to first of all do a plt.figure. So it's going to draw an empty figure. Okay. Then inside it, for categorical feature, we can only do a count plot. So we'll do a sns.count plot. X-axis a feature variable রাখছি. Data নিচ্ছি from the data frame called raw data 2, and hue রাখছি exited, because that's our interest, whether he's exiting or not. And palette, it actually just to give you the color thing. I kept it set 1. If you want to keep it set 2, you can keep it set 2. This is just different plots, different colors here. So if we do that, I'll quickly go through this one. So here you see the first one. Okay, so it's geography. France, Spain, Germany. It tells you যদি এটা entire count নিচে, but percentage plot করলে আরো better হতো, তাহলে আমি বুঝতাম যে কোথা থেকে বেশি কাস্টমার এক্সিট করছে, কোথা থেকে বেশি কাস্টমার এক্সিট করছে না. But to me it looks like the maximum people are exiting from Germany. Can you see that? Zero here means the brown one here means is remaining here, green one, blue one means actually is exiting. Germany থেকে বেশি exit করছে মনে হয়, because এই রেশিওতে almost 50% বেশি, তাই না, compared to that one, right? আর এখানেও exit করছে, কিন্তু there are a lot of people who are staying with it. France অনেক থাকছে. There's a lot of customers from France is preferring this organization, but the German customers are not very happy with this organization. So you can see some interesting things from there, right? Nakina. So আমি দেখতে পাচ্ছি কোন locality also matters as far as the retainment of the customer is concerned. Okay, gender wise আমি দেখতে পাবো, so you can do some gender wise male female, but at a percentage plot could I do better hoto. So this is for tenure wise, I don't think there's much difference here. Okay, almost similar. Okay, anyway, you can see that. Okay, this is for number of products, and we already saw the number of products before. So this is credit card আছে কি নাই সেটাও ম্যাটার করে কিনা, বাট এগুলোকে এইভাবে প্লট না করে পার্সেন্টেজ প্লট করলে আরেকটু বেটার আন্ডারস্ট্যান্ডিং হতো, তাই না, নাকি না, রাইট? অ্যাক্টিভ মেম্বার কি অ্যাক্টিভ মেম্বার না, can that feature also be used to actually see how they're behaving? So we can do some plots and we can have some interesting observation about the data set. Okay, so good, so far so good, Nakina. Are we happy? Yes, sir.
Yes.
আমার
Okay.
একটা প্রশ্ন।
Yes, well,
স্যার আপনি যে ওই যে সেকেন্ড যে একটা ডাটা ফ্রেম তৈরি করলেন না,
raw
raw
data
data,
2.
স্যার এইটাকে কি আমি আমার মেশিনে কোনো ফোল্ডারে করতে পারবো, সিএসভি ফাইল আকারে সেভ করতে পারবো?
Of course, you can always copy that, but আমার কথা হচ্ছে I mean, you don't want to do that, তাই না, দরকার কি, ঠিক আছে, okay, I can always program it, but of course you can do that. মানে you're saying can you save a data frame to my CSV file, এটা বলছেন আপনি নাকি না?
স্যার আমি সিএসভি ফাইলের মতো এটা একটা নতুন ফাইল আকারে আমার মেশিনে সেভ করবো আর কি, ফাইল
Yes, you can do that. You can do that. Sure. ঠিক আছে, I'll show you also. ঠিক আছে, okay. Maybe আজকে হয়তো বা টাইম হচ্ছে না আমার, but I'll show you how to save a data frame to a CSV file as well. ঠিক আছে, okay. Are we good?
Okay.
Yeah, but it's very easy. I think 2_CSV is the code, but I'll show you. Don't worry. Okay, now we are going to do a very important thing, so I would like you to see that. Now you'll see that we have some categorical variables. Problem হচ্ছে machine learning classifiers, there are many classifiers যেগুলা আসলে categorical variables এ ভালো কাজ করে না, so they don't understand categorical variable values, ঠিক আছে. It needs to have a numeric representation, female বলো male বলো, মানে it মানে there are many classifiers who would actually confuse in the values female and male, so or France, Germany and Spain. Okay, so you need to convert your categorical variables into numeric representation. Okay, so let's do that. So I'm going to print off the raw data 2.shape, and I'm also printing out the I'm printing out the head, so you see the first 5 instances. I'm also printing out the shape, so you see that there are 11 columns, and these are these. Okay, remember my categorical features are which ones? Geography, gender, has credit card, is active member. এগুলাকে আমি এখানে categorical feature হিসেবে রাখছি. Geography is a categorical feature, right? Gender is a categorical feature, right? আচ্ছা, has credit card কে categorical feature, এখন tenure কে আমি বাদ দিয়ে দিচ্ছি, number of products কে আমি numeric হিসেবে রাখছি, ঠিক আছে? And is active member definitely is a categorical feature. Is it okay নাকি না? Clear? Yes?
Yes, sir.
So these are my categorical features, and I'm going to write a code, and we will try to understand what this code means. I'm going to write pd pandas dot get dummies, get_dummies. Okay, all right. And I'm going to say, okay, I'm taking the data frame from raw data 2, and the columns that I'm applying these dummies, get dummies on, are the geography, gender, has credit card, and is active member. ঠিক আছে? তার মানে get dummies use করছি on the categorical attributes only, এবং এইটা what will the get dummies do? It will create a new data frame, and this new data frame is stored in this this is the new this is the name of the new data frame called new_raw data. Is that okay নাকি না? Clear? এখন the question is, what does this get dummies do? Get dummies will be converting the categorical variables that you have specified, like these ones, okay, into numeric representation. but it does it in a very special way. So we're going to see what this new raw data look like. So that's why we wrote here new raw data.head. And we are also printing out the shape of the new data frame that we have created. Now, you will see, first of all, when we have printed out the shape of the new data frame, I still have 10,000 rows, but the number of columns has increased to 16. So the number of columns has increased to 16 because আগে ছিল 11 এখন 16 then 5টা নতুন কলাম তৈরি হয়েছে ঠিক আছে so what happened let's see credit score থাকবে age এর জায়গায় থাকবে ওগুলা সব ঠিক আছে যখন আপনি আসবেন ইয়ার ক্ষেত্রে you know এই ক্যাটাগরিক্যাল অ্যাট্রিবিউট লাইক জিওগ্রাফি দেখেন জিওগ্রাফি কয় ধরনের জিওগ্রাফি ছিল জানি বলেন তোমাকে কত ধরনের জিওগ্রাফি ছিল
ফ্রান্স স্পেন
কত ধরনের that's the question 3 so you see geography জায়গায় সে এই তিনটা ইয়া তৈরি করছে কি বলে কলাম তৈরি করছে geography underscore France geography underscore Germany geography underscore Spain now let's see first instances this instance ঠিক আছে first instance where is she from the first customer where is she from France. So let's look at what about here. What happens? You see, when you go geography underscore France, a value to 1. Geography underscore Germany is 0. Geography underscore Spain 0. That means I'm just saying that in this case, geography underscore France is 1. That means this person is from France and not from Germany and Spain. Can you see that? So this is how it actually did that, right, Nakina? Yes. Okay. So similarly, has credit card করেছে has credit card 1 আছে আর 0 আছে তাহলে it will create two more columns একটা হবে has credit card 1 আর has credit card 0 right নাকি না yes something like that right so if you can go here you see gender male gender female so first one হচ্ছে gender female 1 আছে gender male 0 আছে and in fact if you go over here you will see that the first person we have is a female ঠিক আছে so that's why gender female 1 আছে has credit card so pratham person again does he have a credit card pratham person yes she has a credit card and she has credit card 0 to 0 has credit card 1 to 1 because she has a credit card is she an active member 1 so is active member 1 ta 1 hobe or is active member 0 ta 0 hobe right naki na you see is active member 0 is 0 is active member 1 is 1 can you see that naki na yes
sir
So this is how we have converted the categorical features that we have and we gave a numeric representation of them. Can you see that, Nakina? Yes? ঠিক আছে এখন আর কিন্তু ফ্রান্স স্পেন জার্মানি বলে কিছু নাই can you see that এখন কিন্তু gender female male বলে কিছু নাই can you see that Nakina? So we got a numeric representation of the categorical feature. Is that okay, Nakina? Acha, we are running out of time, so we couldn't finish this one. So I want to stop here. But before I stop, one more thing that I want to show you is in machine learning, there is something called one-hot encoder or encoding. One-hot encoding. Now, what does one-hot encoding do? One-hot encoding encodes the categorical feature as the numeric one, okay, and the way we do that is this one এই যে এখানে যেটা করলাম আমরা এখানে we use the pandas get dummy to actually convert the categorical feature and convert into give it a numeric representation of that. This is actually it has done the one hot encoding over here. Is it okay, Nakina? So that's a technique that we use, okay, using in machine learning. So if I say pandas get dummies get dummies so pandas get dummies is also a technique, okay, so it's like the one hot get dummies will produce one hot encoding okay, so we use this get dummies, okay, pandas get dummies to do a one hot encoding on the data set so that we convert the numeric the categorical data, we actually give a numeric representation of this categorical data that we have. Is it clear, Nakana? Yes? Okay. Now, we wanted to finish off the entire thing today, but we couldn't do that. But that's understandable because our machine learning is সবচেয়ে বেশি সময় লাগে এই ইয়াতে কি বলে a data pre-processing. These things do not take much time. Okay? So we'll see those things in the next class. We'll continue with this data set, but I'll upload all the things today. Have a look before you come to the next class. Okay? Because we will not start from the beginning. We'll start after the one hot encoding. Is it clear, Nakina? Yes? Okay? Okay?
Yes, sir.
Okay, so we'll
Okay,
stop
sir.
here. So I'll stop the recording here.